welcome back to Breakdown of Science. I am your host, Jan.
And I'm Michelle. So today we are diving into a topic that's like about transforming just about everything, which is, artificial intelligence.
Mhm.
You've probably heard the buzzwords ChatGPT, deep learning, self-driving cars, but where did all of this actually begin?
Yeah. So to understand this, we have to rewind a bit. The
Mm-hmm.
idea of building artificial beings isn't new. It's ancient, actually.
Yeah.
Way before computers, cultures around the world imagined creating life from non-living matter. For
Mm-hmm.
example, the Greeks told stories of Hephaestus, the god of blacksmiths, who built golden, self-moving, or bronzen, self-moving maidens to assist them. These
I
weren't
think they were
just,
called Autobots, right? Or something like no, Automatons. That's what they were called.
I mean,
Yeah.
they're like huge titan,
Yeah.
basically robotic titans. So they
Mm-hmm.
weren't just, they weren't just robots, they were intelligent and autonomous. They were
Yeah.
artificial.
Yeah. Yeah, and Jewish folklore, there's the golem, which is like a figure made from clay, and they're brought to life through a sacred word. So you see, there are like similar legends in Chinese, Indian, and in Islamic traditions too. And these stories kind of like reveal a deep and human curiosity, which is like, what would it mean to create something that thinks like us?
Yep. And a bit of fast forward to the 19th and 20th century, and this idea starts to take a scientific shape to it. So people actually are
Mm-hmm.
starting to think, okay, what does this actually mean?
Mm-hmm.
Now, in 1818, 1818, yeah, Mary Shelley published her novel Frankenstein, which is more than just a horror story. It's also the first science fiction novel in
Mm-hmm.
history that we know of.
Yeah.
And Frankenstein, I might be a bit biased, but it's a wonderful book. I have it. I've been reading it. I love it very much.
Yeah. I think it's a
And
very well renowned book actually in the world, isn't
it
it?
is. It genuinely is what started science fiction on the road that it currently is. But that's
Yeah.
a discussion for another day.
Yes.
So Frankenstein, it's a bit of a thought experiment on the
Mm-hmm.
consequences of creating life through science.
Mm-hmm.
And then in 1920, Karl Čapek play RUR, or Rozmowy Universali Roboti, introduced the word robot. That's where it comes from. It imagined artificial workers who eventually rebelled against their creators.
Mm. So that theme, like machines rising up, it's still everywhere in pop culture, which you can find literally everywhere. But it wasn't until like the 1940s and 50s that artificial intelligence started moving from fiction to reality. So this is when digital computing emerged, and with it, a question posed by Alan Turing: Can machines think?
Yep, and Turing was a British mathematician and codebreaker. And he also is the person who decoded the Enigma machine that
Mm.
the Germans used during the Second World War. It
Yeah.
was his skills that were used to break that. But
Yeah.
he also created the concept of the Turing test.
Yeah.
This test evaluates whether a machine can imitate human conversation well enough to fool someone into thinking that it, the computer,
Yeah.
is human. If it can, the argument goes that the machine is quote unquote intelligent.
Mm. And then came the first neural network, the SNARC, in 1951.
Snark.
SNARC, yeah. So it was actually a very crude attempt to mimic how rats learn. But things really kicked off in 1956 with the Dartmouth conference, where the term, in code, artificial intelligence was officially coined. And that marked the birth of AI as an academic field.
Yep.
Yeah.
And from the 50s to the 70s, we got what's now called symbolic AI, or in some ways, good old fashioned AI.
Mm.
This kind of AI relied on hand coded rules. You had to tell the computer step by step exactly and in detail of what you wanted to do. One example was Eliza, a program that mimicked a psychotherapist by rephrasing your statements as a question.
But obviously, symbolic AI had its limits.
Mm-hmm.
But it couldn't handle, like, for example, it couldn't handle like messy, ambiguous situations. The kind that we deal with all the time in real life. And there's a book by Marvin Minsky and Seymour Papert, which exposed flaws in early neural networks, which is like when they dried up. And this period is now called the first AI winter.
Yeah. And then, but as evidently, AI did come back, and it came back in 1980s thanks to a powerful technique called backpropagation. That's a learning algorithm that helps neural networks improve by correcting their own mistakes. The field heated up again, with expert systems being used in areas like medicine.
Yeah, and then in 1997, IBM's Deep Blue Beat world chess champion Garry Kasparov, that was a landmark moment because, and then by then,
it was a landmark
yeah,
moment because
it
that
was
was
a
the
landmark.
first time we had a computer, a machine,
Like either
able
actually,
to beat
yeah,
a human in like a cognitively challenging activity.
exactly. And by the 2000s, AI started shifting from rule-based systems to something called machine learning, which meant the system could actually learn from the data.
Yeah, which brings us to today.
Mm-hmm.
The 2010s and 2020s have been dominated by deep learning.
Mm-hmm.
These are advanced neural networks, systems inspired by our brain's sort of neural structures
Yeah.
that use dozens or even hundreds of layers to process information.
Yeah.
They're especially good at tasks like recognizing images or translating languages.
And here's where the things get exciting and also a little bit weird. So you've probably heard of models like GPT-3, DALI, or AlphaGo, and these are like generative models. So they don't just recognize patterns; they create new stuff like text, images, music, like even code. And they're based on an architecture called the transformer. And no, not the transformers from uh, exactly. Which is the backbone, so the transformer, which is the backbone of modern language models like ChatGPT.
Yeah, so we've been talking about going into like types of AI, but let's just wait for a second and ask what exactly AI even is really.
Yeah.
It's not just software. Your calculator, for example, isn't AI. AI refers more specifically to machines that perform tasks which usually require human cognition. Things like learning, reasoning, understanding language, and making decisions.
Yeah, and there are also like several major types of AI. So one is like, for example, symbolic AI, which we mentioned earlier. It uses logic and human written rules. And then there is machine learning, where algorithms learn from the data. And a subset of that is deep learning, where it uses neural networks with many layers. And then there's generative AI, which creates new data like art or stories based on what it's trained on.
Yep. And now let's talk about how the AI itself actually works, what
Yeah.
it is, and so at its core,
Yeah.
artificial intelligence refers to a system designed to perform tasks that would normally require human intelligence, as we mentioned, like recognizing faces, translating languages, reading tasks, or diagnosing diseases. But what powers that intelligence is really just statistics and pattern recognition at a massive scale.
Yeah, exactly. So the AI doesn't think, quote unquote, like we do, but it doesn't understand meaning or have awareness, which you can probably, see it when you
Yeah.
like daily when you ask something, hey, blah blah blah. It works by spotting patterns in the data. So you can think of it like a glorified prediction machine. So you give it enough examples of something, let's say photos of cats, and it learns to predict which features in an image usually mean cat. And the more data you feed it, the better it gets at making those predictions.
Yep, and that learning process of just feeding
Yeah,
begins with training data, massive amounts of it. For
a
image
lot of it.
more than
Yeah,
it actually is so much that it was like recently where it was talking about how because of how much training data AIs actually need,
yeah,
most like companies that take the data have more or
yeah,
less like run dry the specific like images
yeah.
to the point where now AI has resulted in using its own images to train itself on it. So
Seriously? Wow.
yeah, so in the sense is that each image that is being created by AI is a bit inbred in the sense that it's reusing its own thing. Even if it's wrong, it's reusing. And since
Yeah,
it's becoming part of the training data, the
yeah,
AI itself thinks it's correct, even though it isn't.
yeah.
And so it just continues to make that worse and worse with each generation.
Yeah, so
And
don't trust everything that it says. Tell
yeah.
me.
So
Yeah.
for image, as we were saying, for image recognition, it might be millions of labeled pictures. For a language model, it could be billions of words scraped from books, forums, and news articles, even social media. And often the data is taken without consent or credit. And this raises like serious ethical issues, which we'll talk a bit later on.
Mhm. And once the data is gathered, it's fed into, kind of like a digital brain called the neural network. And this then inspired loosely by, our human brain. So, but very simpler. So the network is made up of layers of artificial neurons, which are like each connected to others, and they have assigned weights, so numbers that determine, how important one input is to another.
Yep.
Yeah.
And at the beginning, these weights are random. The model
Mm-hmm.
starts out totally clueless.
Yeah.
But during training, it uses a process called, as we mentioned in the beginning, back
Mm-hmm.
propagation to learn. It compares its output to the correct answer, calculates the error, and then adjusts the weights using a method called gradient descent, which is a kind of like rolling downhill towards a lower error rate.
Mm-hmm.
This process repeats millions of times until the model gets really good at whatever
Mm-hmm.
task it's being trained on. And one
Yeah.
thing is that AIs have a difficulty being able to be trained on multiple things. That's
Mm-hmm.
why we have one AI that's very good at image generation but bad at writing, one
Yeah.
that's very good at writing but not image generation, and one
Yep.
that's good in coding but not images or text.
Yeah. Exactly.
AIs can only be trained in one currently. The AIs can only be trained more or less on one thing specifically, and you
Yeah.
need
Or
to
one field.
yeah
Yeah.
one field, yes, but even in that field, it's usually very specialized learning that
Yeah.
it does.
So it has its own niches,
Mm-hmm.
I guess. Yeah. So there are like different tasks which uses different kinds of architectures, as Jan said before. For example, CNNs, which it stands for exactly, convolutional neural networks, which are, as he said before, great for images. They scan over an image in chunks and they recognize patterns, for example, edges, textures, and shapes. And then there's RNNs, which are recurrent neural networks, which are used for sequences like speech or stock prices. They keep actually the track of past information to understand what comes next. So then there's transformers, which has revolutionized the language processing. So unlike RNNs, transformers can look at an entire sentence or paragraph all at once, which helps them understand the context much better. And there's also GANs, which stands for, again, generative adversarial networks. There are two networks, locked in and creative dual. So one tries to generate fake data, like realistic photos, and the other tries to detect if it's fake. So they improve together, leading to like really incredible lifelike results. Yeah.
Yep. And there's also something called reinforcement learning, where
Mhm.
models learn by trial and error, like training a dog with rewards and punishments. And it's been used to train AI to beat humans at Go, which is
Mhm.
a type of board game that comes
Yeah,
from.
I think it's in Korea. Yeah.
It's in Asia. I don't know the specific.
Yeah.
Then there's also chess and also video games like StarCraft, and
Mhm.
even to control robotic arms.
Yeah, so in short, AI isn't magic. So it's like statistics, optimization, and massive, massive amounts of data and computing power. So it's about like building systems that can generalize from examples, and but they don't understand the world the way we do. Yeah,
Yep.
which is a
And
huge
that,
mistake, by the
yeah,
way.
that is, yeah. And that distinction is crucial
Mm,
because no matter how convincing the output may sound or how human like the image appears, these systems are still just machines that are mathematically nudging themselves towards a lower error rate. So, not entities with insight or comprehension. But building these models takes resources.
a
A
lot of them.
lot of them. Exactly. A lot of them. And training ChatGPT, or specifically GPT-3, which is a
Mm,
more recent one, alone consumed roughly as much electricity as an average US household would use in over 100 years. That's actually true. And that's just the training phase. After deployment, inference across millions of users burns through even more power continuously. Data centers now rival the airline industry in carbon emissions, and that's projected to increase drastically as models grow larger and more widely deployed.
yeah. But you guys have to think the energy is only one part of it. So these systems, they consume staggering, like a lot of amounts of water that is like often hidden from the public view. So the water is actually used to cool the massive servers during both training and the everyday usage. And some estimates that a single large AI model can consume like around 700,000 liters of clean water, which is like enough to produce hundreds of thousands of plastic water bottles. And the companies tend to build these centers in regions with cheap electricity and tax incentives. I mean, obviously,
Mm-hmm.
often placing a strain on already vulnerable local water supplies. So places like Iowa, Arizona, and Chile are seeing this
Chile.
firsthand. Yeah, Chile. So sorry.
Mm-hmm.
Thanks. They're seeing this firsthand because water diverted to cool data centers while the residents face drought conditions.
Yep. And that's not just about scarcity.
Mm,
The water used returns to the ecosystem at elevated temperatures, which disrupts local aquatic ecosystems,
mm,
contributes to thermopopulation, and
yeah,
damages biodiversity. The resource toll is so high that researchers have started talking about the quote unquote hidden extractive footprint of AI. So basically,
yeah.
the energy, minerals, and water all being pulled from ecosystem and communities that rarely benefit from the tech they're helping to sustain.
Yeah, so that definitely sparked a movement for green AI, which is to push, which is like a push to make models smaller, definitely more efficient, and very less environmentally destructive. So some labs are experimenting with model pruning, knowledge distillation, and hardware-specific optimizations, and others are trying to run data centers on 100% renewable energy or also using liquid immersion cooling, which is instead of the water-based systems. But right now it's still more of an aspiration than a norm. So these incentives are more skewed toward building even more larger or powerful models, regardless of the environmental cost, and that sucks.
Yep.
Yeah.
And speaking on this, now we're entering the ethical issues, and we cannot
Mhm.
forget that at all.
Yeah.
As we were, so an AI system can reflect and sometimes amplify social biases.
Yeah.
The reason it does that is because what the model is trained on, which is usually text, is largely
Yeah.
taken from social media. And
Yeah.
in most cases, the most viral stuff that becomes popular, that most AIs take,
Yeah.
are media that is either bigoted, racist, misogynistic, or some kind of negativity to it, or some sort of misinformation. And this then gets fed into the AI and treated as the correct information. So this results in a facial recognition system who might misidentify people of color. A hiring algorithm might prefer male candidates over equally qualified women. And these aren't just technical glitches. They are a mirror of the data they're trained on. Data that
Yeah.
often reflects real world discrimination, as I said.
Yeah. And then there's also another major ethical concern, which is gaining a lot of attention. So the way AI models are trained, so it's the way they are trained in the first place. So there are many large language and image models which are, built by scraping massive amounts of data from the internet, so books, blogs, art portfolios, scientific papers, music, and a lot of others. It sounds great, right? But free information to learn from, and that's the problem.
Yeah, yes, exactly. And here's why. Most of the data was never given willingly. Writers, artists, and creators are discovering that their work, sometimes copyrighted, sometimes personal, has been quietly scooped up to train AI systems. These
Mm.
models can now generate text or images that mimic their style, often without permission, credit, or comprehension, and in many cases, the creators didn't even know this was happening.
Yeah. So it's like feeding a machine an entire museum's worth of paintings and then selling the prints of its AI made art without ever mentioning the original artist. And that definitely raises serious questions about, the intellectual property, the consent, and also the exploitation of creative labor. I mean, is it innovation or is it theft on a digital scale?
And some lawsuits are already underway.
Mm.
Authors, visual artists, and musicians are pushing back, demanding
Yeah.
transparency and accountability. They're asking, shouldn't creators that have a say in whether their work is used to train AI? Shouldn't there be a way to opt out or at least get credit and fair compensation?
And this is not just about ethics, it's also about trust. When people find out that, the AI systems are built using their unpaid labor, it definitely decreases the public confidence, especially when those systems are now being used to replace or undercut the very industries those creators belong to.
It was recent this year, I think, where,
Mhm.
um, if I remember correctly, Hayao Hayao Mizuyaki, basically
Mhm.
the co-founder of Studio Ghibli,
Yeah,
he was recently told that there has been an image AI
yeah,
that takes the photo someone gives them and
yeah.
basically generates an image in the style of
Of Ghibli.
Studio Ghibli.
Yeah.
Yeah,
I think it
and
was in WhatsApp, wasn't it?
I think so, but I don't remember exactly.
Yeah.
Uh, and when Miyazaki heard about this, he called, uh, he viewed these AI generated art
Mm.
as, and a quote from him directly, was an insult to life itself and a
Yeah.
grotesque representation of human expression.
Yeah.
He,
Definitely.
yeah, he believed that the AI lacks the genuine human experience and
Yeah.
emotions necessary for creating truly meaningful art. And that's
Yeah.
something that a lot of artists are continuously expressing towards the current situation of AI.
Mm.
And so now, as AI continues to evolve, one of the biggest challenges ahead isn't just technical, it's legal and cultural. How do we balance progress with respect for human creativity? How do we make sure the future of AI is built fairly, not on stolen ground? And we also have to think about jobs. AI isn't just automating repetitive tasks on factory floors anymore, it's going after intellectual and creative works too, as we were just saying. We're talking about writers, designers, illustrators, composing music, and even coding. And that's not just speculative, it's already happening. Companies are using AI to churn out blog posts, generating advertising copy, produce consumer support scripts, and design logos.
Yeah. I think there are like several examples. I think there was one for Duolingo. I
Mm-hmm.
forgot. Like, he wanted to use, what did he say again? He said something about
He
AI.
wa- so he wanted so it this happened like a couple of weeks ago,
Yeah.
where the CEO of Duolingo came out saying that Duo is not going to be an AI first company,
Yeah.
and what they are saying, what the CEO said was that we want to replace our contractors with
Yeah.
AI workers. So
Yeah.
basically, they are still keeping what they have currently in contract, but they
Yeah.
don't want to renew the contracts with actual contractors, with actual companies, or with actual people. They want to continue on with AI in it.
Yeah.
And this sparked a lot of people stopping using Duolingo, even if they have been on like year-long streaks, just
Yeah.
stopping it because we now are in this position of we actually have a forming uniform front
Yeah.
towards going against AI.
Yeah. I think there was also another example where an artist, like, I think it was in Spotify, I'm not sure, but they put out an album, like a normal album, but inside, like the music, there was no music, it was just blank, nothing.
Yes,
And that was also
a
like,
lot of artists actually. I don't remember all of them. I think maybe Lady Gaga might have done one. I think I heard, but not sure. I have to look into it.
yeah,
But a lot of artists did post albums of just more or less silence,
yeah,
uh,
exactly. That
as
was the
a
word I was
way.
looking for.
Yeah, it was to like go against these scraping AIs who were
Mm,
just stealing their work, less
yeah,
popular and more popular artists' work,
yeah,
by just inputting a lot of just noise or emptiness to
yeah,
confuse the AI.
yeah,
And a lot of artists as well have been using an interesting uh, thing with their mainly digital art, where they
mm-hmm.
put on a very low opacity on one of the layers of their drawings just squiggles of colors that
Yeah, I've
more or
seen
less,
that.
yeah,
I've seen
where it doesn't look, either it's in a way that looks artistically nice to us humans,
that. Mm-hmm.
or is not visible at all because of the low opacity.
Yeah,
But AI picks on it, and when
yeah,
it does its image analysis, it pixelates things, and
yeah.
that disturbs the image when it's doing the analysis, making the data unreadable and void.
Mm. That's an incredible way to, confuse it.
Yeah, and I've also seen some people, I think on Twitter a bunch of times, where they're posting images from companies like Mickey Mouse or Marvel and stuff like this to
Yeah,
say, "Oh, I wish I had this as a photo for T-shirt. This drawing is so good. All this."
yeah,
Because there was this one company who was scraping art that it found on Twitter
yeah.
and creating uh, on a website, putting images of T-shirts with those drawings on them without consent of the artist. And people were posting now like the logo of Disney or marvel and saying, "Oh, I wish I had this at a T-shirt," and so
Yeah.
to cause the AI to do to have it to basically create a copyright infringement, so that
Mm.
the website and account gets taken down or at least get lawsuit.
Yeah. So as you can see, this way of automation doesn't hit everyone equally. While tech companies profit, the workers in media, design, and even programming are suddenly being told their skills are replaceable. And we could see a serious widening of economic inequality. I mean, yeah. And there's also a small group which controls the tools, and the rest are left competing with the machines. Awesome.
Yeah, and as we were talking about scraping, we have to also talk about accountability.
Yeah.
As AI takes on more responsibilities, from diagnosing diseases to approving loans to controlling self-driving cars, what
Mm.
happens when it makes a mistake? Who's responsible? The developer, the company, the user? Right now, that legal and ethical frameworks are lacking far behind the technology itself.
Yeah. And it's not just a legal problem, it's again a trust problem. Because people need to know that when AI makes a decision, especially when it's a high stake one, someone is definitely accountable. Otherwise, the system becomes ungovernable, and that's definitely not good.
Yeah, and this is a science podcast, so
Yeah.
AI is being used in science as well.
Mhm.
So
Yeah.
again, we said about how AI has been replacing human labor, and
Mhm.
while that's true, not all AI applications are about replacing human labor. Some of the most exciting and a bit more complicated uses of AI are happening in science, where
Mhm.
research are using AI not just as a tool but as a collaborator in discovery.
Exactly. Now let's break that down. So first off, when we talk about AI in science, we're usually talking about machine learning, especially deep learning. So these are just algorithms that I've said before that they can find patterns in massive data sets and then make predictions and then even generate new hypotheses. And in some case, they're uncovering things that we as humans might have missed entirely.
Yeah, and for example, we can go into some of the fields. For example, in
Mhm.
biology, for instance, AI is mainly being used in genomics or
Yeah.
genetics in general. And
Yeah.
tools like DeepMind's AlphaFold recently cracked the protein folding problem,
Mhm.
something that scientists have struggled with decades. That
Yeah.
has huge implication for medicine, drug design, and even our understanding of evolution.
Yeah. In terms of medicine, AI is being also used for diagnostics, like reading X-rays, MRIs, and also the pathology slides. So some algorithms are just as accurate or even more accurate than human radiologists in spotting certain conditions. And it's also being used to predict disease outbreaks. They can also personalize treatment plans and also identify drug candidates at lightning speed.
Yeah. And over in chemistry, AI is used to model molecular behavior, predict reactions, and even discover new materials. Some chemists are using generative AI to quote unquote design molecules that might be good drugs or polymers or even components for batteries. It's a new kind of chemical intuition based on data.
Definitely. In physics, it helps to process data from particle accelerators like CERN
Sir.
and CERN. Yeah,
Mm,
I like to pronounce it every single alphabet. But anyways, it's used to filter through mountains of collision of data to find rare events, and it's also been key in gravitational wave detection, which is sifting signals from cosmic noise.
yeah.
Yeah.
And collision data, that's referring to when they're accelerating uh, protons, which are basically
Yeah.
positive parts of atoms,
Yeah.
speeding them up at near light speed, and
Yeah.
then the two of them, and then smashing them together
Mm.
to see what happens. That's like the understanding of what collision data. It's actual collision.
Yeah, like
And
literally.
talking about cosmic noise,
Mm,
astronomy has a similar story. AI
yeah.
might process data from sky surveys, identifying exoplanets, classifying galaxies, or even predict solar flares.
Mm,
And there's also projects like the Square Kilometer Array, which will heavily rely on AI just to handle the volume of information.
yeah. AI also helps like in engineering and robotics as well. So it helps to design more efficient systems. They also help to optimize manufacturing and also improve autonomous control like drones, robotic arms, or even smart infrastructure. And in civil engineering, it can help, for example, monitor bridges or even buildings for signs of stress or failure.
Yeah.
Yeah.
And in mathematics, AI has already discovered some new theorems or at least proposed some patterns that
Mm.
human mathematicians are now exploring. And in this case, it's more of a collaboration and not a replacement.
Yeah, and even in social sciences are tapping inside, in this AI field. So AI is also analyzing social media patterns, political discourse, and definitely economic trends and human behavior at a scale which is, never been possible before. And it's powerful, definitely powerful, but also very risky because, biases in the data can lead to biased conclusions.
Yeah.
And that is,
So,
yeah.
yeah. Now, okay, we did talk about types of AI. So, what specific ones are we talking about here? So, uh, there are four types that are mainly being used. There's supervised learning, which is common when we have labeled data sets, like identifying tumors or classifying galaxy shapes. And then we
Mm,
also have unsupervised learning, and it's used to find hidden patterns like genetic subtypes or chemical families. Then, as we mentioned before in the beginning, there's also reinforcement learning, which powers autonomous agents like uh, robotic scientists, as they're being called, these collaborative AIs, or
mm,
lab automation systems. And then there's also generative models like ChatGPT and diffusion models that are helping generate text, code, hypotheses, or even images for publications or simulations.
yeah, but there are also like of course hybrid systems that combine AI with symbolic reasoning or traditional simulation methods, and of course these are especially useful in physics and in systems biology.
Yeah, but there is, of course, uh, a debate. The use of AI in science isn't without controversy.
Yeah.
And some scientists worry that reliance on black box models, especially deep learning, undermines transparency and interpretability, the ability to be interpreted.
Yeah.
And so, what that means is that you might get the right answer, but not know why it's right.
Yeah, and others point out that AI might be amplifying systemic issues like citation bias, gender, race disparities in medical data sets, or even reinforcing outdated scientific assumptions. And there's definitely a concern about oh my god, reproducibility. So if a study uses proprietary models or data, can anyone else validate these findings? Yeah.
And yeah, and then there's also the hype factor.
Yeah.
Some journals and funding agencies are being flooded with AI buzzwords.
Mm,
There's pressure to include AI even when it isn't appropriate, which risk diluting real scientific value.
yeah. Even in science, where the promise is huge, we have to be careful because, sure, AI is changing how research is done from hypothesis generation to data analysis, but it doesn't mean it's all progress. So when you have black box systems producing results that no one can fully explain, that's not argumentation, that's a risk, actually.
Yeah. Exactly. It's tempting to frame AI as a tool that, quote unquote, helps scientists. But we
Yeah.
need to ask on whose terms. If AI systems if AI systems start dictating how we do science, as in what gets published, what gets funded, what counts as valid data, that's a real problem. It shifts far away from the researchers and towards an opaque or vague algorithms that the companies that opaque algorithms that the companies that own them, they
Yeah.
get the power.
Exactly. And let's be honest, use it wisely, transparently, and ethically sounds great on paper, but in practice, well, that's a different question, isn't it? So most of these systems are, as I said, proprietary, trained on data sets which no one can audit, and they're definitely operated by corporations with financial incentives, and definitely not with scientific integrity.
In most
So
cases,
that's
yeah.
not, yeah, exactly. And that's not a neutral tool, that's a structural vulnerability.
Yeah.
Yeah.
And looking ahead, AI's future won't be built just by engineers.
Mm,
It'll need ethics, psychologists, artists, legal scholars, and everyday users. And because this is no longer just a tech issue, it's a social one,
yeah,
societal one.
because it impacts everyone, you know?
Yeah,
Yeah. And the goal should be, definitely human centered AI, so systems that serve the people and respect their rights and also enhance human dignity. Because at the end of the day, AI isn't about machines, it's also about us, because the way we use it definitely has, an impact on it.
yeah.
Yeah.
Uh, Especially because of how the training data is being gathered for
Yeah,
this. It's being
exactly.
taken from creative sources without consent, and
Yeah.
that removes part of humanity when it generates something that it has stolen.
Yeah.
But that is all for today's episode,
Mhm.
the breakdown of science. If you enjoyed this deep dive into AI, please leave us a comment and share this episode with others who might be interested in learning more about it.
And if you have any questions, feel free to comment or even send it us in our Instagram so we can do another Q&A episode next week. So make sure to follow us on Spotify, YouTube, and Instagram, like if you get so that you can, get notified when the episode comes out. So yeah, see you next week.
Yeah. See you then. Bye.
Bye.